is doing something else. Cool. Hi everyone. Thanks for coming to join my very unrehearsed, very much let's see how this goes presentation on CI pipelines. So for those of you who don't know me, I'm Iain. I'm a former HackSoc, former security person. I graduated here in about 2016. And I'm now the containerization practice lead at NCC Group. So I spend most of my time either hacking Kubernetes clusters or Docker containers, or more recently, CI pipelines and the kind of integrations around them. So what I'm hoping to cover today is a brief introduction into CI/CD, talk about kind of why people are using CI and what the benefits are to developers, to security people, to anyone. I'm going to demo some attacks. I say I'm going to demo them. I'm not entirely convinced that the Wi-Fi here is going to hold up, so I might just talk through some of them. And then I've got some war stories from some of our recent engagements that we've done, some of the attacks that we've done on client gigs. And then hopefully, at the end, some useful blue team advice so that if you are running pipelines, you've got a better idea of what you can do to secure them and to make sure that these sorts of attacks don't work against your environments. So mild disclaimer, these findings are kind of skewed towards containers because that's what most of my interest is in. A lot of the time we're finding pipelines are running using containers as a backend anyway, so it's fairly common. But just again, not every attack is going to be container related. Most of the ones I'm going to talk about will be. And also I've taken a bit of kind of dramatic license. We've changed some of the client detail. We've changed client names, obviously. We've removed any details, and there's one attack chain that's a combination of a couple. But effectively, these are all representative of what we are seeing in the wild at the moment. So, CI/CD. This is basically, the TLDR of this is, CI/CD is automation in your build environment. So instead of having to write some code, ship that code off somewhere, have someone else pick up the code, deploy it into another environment, do your testing, have another user go, right, these tests all passed, I'm going to pick everything up and move it into production, and kind of a 1 month lead time to get something into production. A lot of pipelines are being written just to make this process quicker. There are other benefits as well. So allowing your developers to move faster and work more centrally. Working from a central code base that has the same tests applied kind of gets rid of these tests pass on my machine, so what's the difference? It's a lot easier to not worry about having to reconcile code as long as you know how to use Git, which I don't really. I'm very much in the school of delete everything and start again if you get a clone error. And again, actions are performed on central compute resources, so you can get away with less powerful developer laptops. I mean, let's face it, most devs are using overpowered Macs anyway, but you can technically write the code on a Raspberry Pi, fire it off to a central cluster, and the beefier compute tasks will happen centrally. And in theory, devs are made more efficient by not having to worry about all of this automation, because a DevOps approach will lead to devs just write code, and then the magic automations make the code do stuff, which we'll talk about a bit more later. So the CI part of CI/CD, continuous integration, this is kind of your testing phase. So if you've got good unit tests in your code base, then every time you do a commit, you can have those unit tests run automatically. You can make sure that your code actually works and does what it's meant to. And obviously, the better your test suites, the more effective that will be. It also allows for more testing before a merge. So if you make a merge request for a couple of branches in Git, you can say, right, before this is automatically approved, just make sure that all the code works between my new dev branch and my production branch. There's also this move for shifting left, so moving security further and further left in the workflow. Instead of being like, we've spent months building this thing, we're going live on Monday, let's get pen test, which we still see all the time. Integrating security tools into a pipeline can definitely lead to a lot better, more regular security feedback. So you can be doing things like, if you're running infrastructure as code, you can run things like TFSec, and then that'll say, right, this infrastructure is going to be built with, this Terraform code has been written and it's got security groups open to the internet. Let's flag that in your build pipeline and say, hey, are you sure you want to do this before you deploy? The same with things like code quality scanning or secrets checking. I know there's a big drive to let's get rid of all the secrets from my build pipeline, so you can basically prep your code for AWS keys or things like that. and then flag them and say, hey, this commit has tokens in, that's really not good. I'm going to alert you now, rather than 5 months later when someone from HackerOne emails you and says, hey, I've got root on everything. And again, more testing on smaller changes in theory means faster and more actionable feedback. So if you do a small commit and suddenly builds start failing, you know that it was probably on just a couple of lines of code rather than absolutely the entire code base needs to be debugged. So that's the CI part. The CD bit is continuous delivery or continuous deployment, depending on what blog you're reading at the time. Basically, this is the bit where once your tests are passed, you can deploy code to the next environment. So if it's a merge request, you can say, right, all of my unit tests are passing, there's no glaring security issues in this environment. What I'm going to do now is take all of this code and redeploy into a staging environment. So you say, right, let's make sure that everything actually runs in a representative environment for what the web app or API or whatever should look like. And again, once you've decided that everything's okay in staging, you can make another request and say, right, just take exactly what you've built in staging, lift it up and put it over there in prod. And because this is programmatic, you can get much faster migrations. So in theory, if you've got a good enough test suite, I can write some code and say, right, I've made these changes. I'm going to say git commit, git push, and then suddenly my code is running in production with a relatively good degree of confidence that it's not going to be completely broken. In theory, doesn't always work. So in terms of the tech we're seeing, the pipelines are normally something like Jenkins, GitHub Actions, GitLab CI. There's a whole bunch of other ones. There's Azure DevOps. AWS have code commit and code deploy. I'm sure there's something googly that I can't remember the name of. There's loads of these. Circle CI is another one that we see quite often. But on the whole, mainly Jenkins, GitHub Actions, GitLab CI. And then, obviously, these actions, they're defined through the pipelines. The compute power has to come from somewhere, and this could be basically anything. We see bare metal machines, we see VMs. Normally, we see things like containers or occasionally serverless. So I have seen a couple of instances of testing being performed in like AWS Lambdas, which is a bit more unusual. Generally, the Lambdas are the artifacts, not the test compute, but it can be done. And effectively what's happening is when you make a git commit, your CI of choice is picking up the code and saying, right, so Jenkins will say, oh, I'm watching this repo, there's been a new commit, let me take this code and put it into a container to run the actions that I want to run. So from an attacker's point of view, now that we know roughly what a CI/CD pipeline can look like, what I've got is a thing that I can give code to, and that thing will run that code and then will probably have credentials to put the code into production. So as an attacker, if I can modify the code going in, I can modify the artifacts coming out, which is fairly valuable. Another thing is quite often we see that in order to keep costs down, there's one build environment being used for multiple projects. So if you've got 6 or 7 Git projects or several hundred teams, quite often we'll find there's a Kubernetes cluster running and it's doing the building for every single one of those projects, essentially. If I can compromise the build pipeline or the compute power behind it, there's a fairly good chance that I can compromise every single one of those projects at once, which is suboptimal to the devs. So as an example, I've got GitLab CI running. I'm using a Kubernetes cluster behind the scenes, providing the compute resource. And effectively what I've done is there's a nice and easy Helm chart. For those of you who are familiar with Kubernetes, Helm is like a package manager. You just say Helm install GitLab runners, give it a token for your GitLab instance, and then GitLab has the ability to talk to Kubernetes and say, I'd like to make these jobs, I'd like to run these containers running certain commands. Kubernetes will then spin up the workloads and you'll get the output back in GitLab. Actions in this case are run as Kubernetes pods. It doesn't have to be, again, you can use just a VM or something. Generally, you get better segmentation using something like containers. We've seen issues before where customers have just been using a single VM, and if you just get a shell and then go .. get to the root of the drive and you find the build artifacts for 17,000 projects. Generally not a great idea. Doing this in containers does give you a nice clean environment every time, which is always nice because you know it's not a problem with a build artifact from a previous run is interfering with my current run or something along those lines. So my infrastructure basically looks something like this. You've got GitLab. When I make a request, GitLab's going to go, hey, I would like to make some pods, please. Hello, Kubernetes I, please make these pods. Kubernetes is going to do its magic as orchestration layer and go, okay, hello nodes, please run these containers. Nothing too strenuous there, really. And then for GitLab CI, this is what the syntax looks like. Jobs tend to be written in YAML. YAML is yet another markup language. It's a wonderful, horrible, more human-readable version of JSON that's whitespace sensitive. And almost every time I try and write something, I end up putting an extra space in somewhere and everything dies. It's not horrendous. It is more readable than JSON, that's for sure. And it's not XML, so it's got that going for it. But yeah, basically every GitLab, every CI environment uses YAML in some format. The syntax is different, but they're all roughly the same. So if we look at this test job, we've basically got a build stage. You can split your jobs up into stages, so if you need to prepare an environment before you do actual deployments, you can. All of the jobs in one stage will run at the same time. In this case, I've got a test job, and all it does is say, hello, I'm testing GitLab CI. So it's just an echo hello world. I might be able to actually show this running, assuming my VPN hasn't dropped. So what I've got here is a pipeline, CI/CD pipelines. I don't know how well you'll be able to see this. I will try and zoom in. Is that big enough for people to see? Kind of. So what you can see here is I've got pipeline number 71 has run, and I have 6 tasks that have been run. So in the test stage, I've got my test job, then I've got some Terraform happening. In the deploy stage, I've got more Terraform, and then I've got the hacks that we'll come on to later. And if I go into test job, what you can see, again, this might not look great for those at the back, but I hope you can see it. Effectively, we've just got the echo hello world at the bottom here. We get some outputs. You'd probably be doing something more complicated than just saying hello world in a real environment. We'll get onto those later. But that's roughly what a job looks like in GitLab. Again, using something like Circle CI, this will be different slightly, but the fundamentals are the same. And there's screenshots just in case my VPN dropped. So yeah, basically you can see a couple of jobs ran. We've got some terminal output that really doesn't look good on that screen. So as a better example, I've got a pipeline written that I as a developer can make some code. I can write it. I can say to GitLab, okay, I've done a deploy. GitLab can then run Terraform, which you saw in a couple of slides ago. And then Terraform, if anyone's not used it, it's infrastructure as code provider. I can define a bunch of AWS resources in Terraform. And when I do a Terraform apply command, those resources will be spat out in a running AWS Lambda or whatever I'm doing. In this case, what I'm doing, I've got a Node.js, very, very basic API that I'm uploading the code to S3, and then Lambda picks up the code from S3 and says, right, I'm now going to run this Lambda. So I have a Lambda here that says, to do, write my slides for security. This is running, I don't know how well you'll be able to see it, in an AWS Lambda at the moment that I can view in my account. What I'm going to try and do is actually modify that code. Let's just go up to the correct bit. Slides are written. And if I go git add and then git commit and then git push, what we should see is if I now go to my CI, we've got a couple of pending jobs here. So if I now go into the pipelines and select job 72, what you can see is I've got my 3 stages of the pipeline running. So at the moment, it's about to do the test tasks, and then it's going to actually run the deployment. So you can see there the stage has changed. These tasks are actually running, and if we click on one, we'll see output from the containers that are running. If anyone's really interested, what we can actually do is do kubectl get pods And you can see there's a couple of containers running. These will probably appear and disappear over the next few seconds. These are basically the actual workloads running from the back of these jobs. So because I've got admin on my Kubernetes cluster, I can go in and see the pods running, and actually I could mess with them, interact with them directly rather than through Git commits. We'll come back to that later. And over the next few minutes, that will deploy, and we should see the changes. So this is what my code looks like for the Terraform deploy stage. I'm saying in the deploy task, I've got a rule saying if the project name is not my template, basically I've got this all templated on my system. If it's not the template, then run Terraform init. This backend config just says use S3 for my storage where the Terraform state is, and then make these changes, make it happen. And I've said only make these changes, only run this task if the changes have been made to the Terraform /star or demo/star directories. The reason for this being, if you make a change to your README or something, you probably don't want to rebuild your whole environment because these pipelines can quite often take a long time to run. So there's all sorts of logic you can do in here as a dev, which is quite useful. So that was a quick whip around of what the pipelines look like. Anyone got any questions so far? Is that vaguely making sense? Basically, code goes in, code does stuff, built things come out. Before I go into war stories, let's see if my Lambda has changed. It has. So that commit has gone through the build pipeline, and the changes have now been made so that my slides are written. Good job, me. Those of you who were speaking to me in the pub last night will know that that was only the case about 20 minutes ago. And I've been talking for 17 minutes. So, a few war stories. If anyone's read the NCC blog post we did recently on some real-world examples of this, you've probably heard these before. If you haven't read it, as the author of it, I'm going to go ahead and say you probably should. It's quite interesting. But I'm going to go into 4 examples of some compromises we've had through CI pipelines. The first one, this was a couple of years ago, probably the first job that I remember involving a pipeline. We got asked to test a Kubernetes cluster. And it turns out when we got there that we went, actually, we're not going to give you any access apart from you can be a dev. We will give you access to a developer's laptop with Git write permissions onto a single repository. So we were effectively just a normal dev. The codebase was an Apache Maven project. The consultants on this kind of went, oh, what do we do? Let's grep around for some interesting bits. And we found that there were external dependencies being loaded in from a config file that we could modify. So we were able to say, as part of the Maven project, your dependencies are from these Java files. So we did a bit more recon, trying to work out what was going on. We worked out that they were using Jenkins for the pipelines. And we were trying to work out the internal network infrastructure as well, trying to work out how dependencies were loaded and if there were any restrictions on those. As you can possibly guess, there weren't any restrictions on where those dependencies could be loaded from. So we did the really, really, really technical thing of generating a interpreter payload through Metasploit, nothing fancy at all, no AV dodging or anything. And then we just loaded that on a Python simple HTTP server on a dev laptop and said, okay, you can load this jar file from here. So Jenkins runs and goes, oh, I need to go and get this jar file and run it as a dependency. Loads up Meterpreter, conveniently calls back to our C2 server. I say C2, Metasploit server sitting on the internet. C2 makes it sound far more grand. So basically, we've got a shell in the build environment. That shell was limited to just the build Kubernetes pod. It wasn't able to do anything particularly massive. But we've got a shell. Everyone likes shells. It's a good starting point. So we did a little bit more recon. We did the whole cd ... let's go to the home. Unfortunately, clean environment, so only the required build bits for each of the projects. But what we did find was the container image that was being used, for some reason, had an SSH key in it. So we were grepping around, we ran some kind of secrets grepping tooling, and we found an SSH key and went, that probably shouldn't be there. Is it password protected? No, it's not. Okay, brilliant. What can we do with it? So As you may have guessed from the fact that we were able to get a shell back, there was no restriction on internet access inside the build environment. It could reach out and go to wherever it wanted. We installed Nmap, we did some more recon, and wouldn't you know, we found some more servers running OpenSSH server. Again, nothing particularly clever here. We just went, right, what else is there? Mapped the local subnets, and we found all of these servers available. And we suddenly went, well, we've got a key, we've got servers. Wonder what happens if we put them together. SSH in using the keys, little bit of username brute forcing. I think the usernames were like admin or something really guessable. And what we found out was, for some reason, and I will never understand why, their main build image had an SSH key that logged you in as root to their Jenkins master nodes. So we were able to just SSH into anything we wanted, basically, in their entire build environment. So we jumped in, started running PS across all of the servers to work out what was running. Generally, the way secrets management is handled is through environment variables in these pipelines. So we were able to go, right, let's just run PS, see what running build processes are, what end variables they've got, and we found a Kubernetes kubeconfig file. If anyone's not experimented with Kubernetes before, don't do it, it's awful, but it's also brilliant. Authentication's handled through another YAML file, and then generally either a token or a client certificate. This kubeconfig file that we found pointed to their production running environments as cluster admin, which is wildcard, you can do whatever you like. So we were able to run kubectl commands. And at this point, we have admin over the client's running production environment. From a interpreter shell, SSH keys, dump more secrets, we've got access in prod. And again, at that point, that was just root on a production server, so we could modify code, we could interact with customer information, we could basically do whatever we liked. Again, not ideal for the customer. It was fairly fun, given that they said, oh, we're not giving you any access, let's see where you can get, which any pen testers in the room will know that's a red rag to a bull. The next pipeline that I wanted to talk about was a little bit different because it started off as a red team. So we had spent a couple of weeks trying to get into this customer's environment. They were fairly locked down. We couldn't get anywhere. Eventually, we got some phishing to work, got this set of credentials, found a pipeline that was exposed to the environment, and we went, right, these guys are really clued up. They're quite strong. Their perimeter's good. Let's see if we can do anything at all with this. This was just a development environment, and we couldn't see any pipelines that pushed into production. We couldn't see anything other than basically unit tests. So we thought the odds of this being useful are maybe not amazing, but hopefully we'll get something. So anyway, modify the pipeline, take the first job. We found one that hadn't been run for a few days. Went, that looks about right. We'll modify this, make it just run printenv. So all we're doing is listing out the environment variables. And as it happens, there was credentials for an Active Directory service account. For some reason, again, I don't know why, that service account was domain admin for their entire estate. I can kind of understand, like, oh, I need credentials to load something into prod, or I need to be able to read from a file server or something. I will never understand why these were domain admin, other than I assume, oh, it makes it work. If you give it all the permissions, then you can't ever have a permissions error, right? So we'd spent weeks against this pretty hard target, and then we ran this pipeline and got domain admin. Amusingly, the follow-on from this was someone got an alert to say their pipeline had failed, and they went, oh, that's not good, and re-enabled the pipeline. And no one actually bothered to look into what the creds could do until about a week later, when we debriefed with the client and said, hey, see that secret that the pipeline failed for? Yeah, we won then. So fairly successful there. The next one was a bit more complicated. So the previous two have basically been, we've got access to a Git repo that the config's in, so we can make changes. And as I said earlier, what you're feeding in gets executed, so that's kind of expected behavior. The third one was a bit more interesting because we found an app being tested, and it was deploying to this test environment in the middle of the pipeline that was vulnerable to server-side request forgery. So we were able to, in fact, it was a local file read as well. So we were able to read arbitrary files on the worker. And again, if anyone's heard me talk about Kubernetes, you'll know I get very annoyed at RBAC. One of the things Kubernetes does is mount a service account token into every pod that's run by default. So even if you don't need to talk to the Kubernetes API, your pod has credentials that let you talk there. And it's in a fairly predictable location. It's in var run secrets kubernetes.io service account token. So we just said, right, we're going to use this SSRF to cap that file. We did a bit of recon, or we used the LFI to do this. We did a bit of recon. If you ever find yourself with LFI and want to know if you're in a container, catting etc hosts is quite a good one, because if you're in Kubernetes, it actually says at the top, managed by Kubernetes. So that gives you a bit more targeted recon. It's quite nice. We had this service account token and went, I wonder if we can actually use this. It wouldn't be a very good story if we couldn't use it. So as a brief aside, Kubernetes containers have these authentication tokens. Depending on the cluster's RBAC, you can do some things, you can do nothing, you can absolutely rinse the client depending on the setup. And as an aside to the aside, because I love going down tangents, if anyone runs a Kubernetes cluster in AWS's managed EKS, the way authentication is handled is through a configuration map in the kube system namespace. Basically, what you do there is you say AWS role ID on the left, Kubernetes role on the right. And the AWS roles do not need to match the AWS account, so this can be used for cross-account access quite easily, which we didn't know until we tested this about 11 o'clock at night, because it was an American gig. For some reason, and you're probably fed up of hearing me say that, but misconfigurations exist, we use the LFI and the SSRF stuff. We got access to the config maps. We got access to Kubernetes. This account had the ability to edit config maps, including the config map in kube system. So we basically said, okay, we're going to modify this pipeline, or we're going to modify this config map. Iain's AWS account now has cluster admin access in the cluster. So we generated authentication tokens in my account, put them into a kube config, ignored some TLS stuff, and then jobs are good. We had cluster admin over, that's meant to say cluster, not clustered. We had admin over their build pipeline. This was really weird because we weren't at the start of the pipeline and we weren't at the end. We weren't in a position where we were directly able to modify the code being run, but what we could do was modify any pod, or we could interact with any pod that was being run because we had access over the middle bit of the pipe. What we wanted to do was try and get either back to the Git repos or onwards towards the production environment or whatever the artifacts were. So, Kubernetes cluster, we've got access in the middle. What can we do? And effectively what we were able to do in this case, we ran kubectl get pods. Let's just list all of the pods that are running, dump out their environment variables like running PS on a build server. And we found a whole bunch of secrets. So there's a whole load of secrets that get added in when you're running. Any of your build secrets get added. There's also a whole bunch of tokens that authenticate back to the Git repos. These are short-lived tokens that only last as long as the job does, which is a little bit unfortunate. Because, effectively, quite often a Git, especially in Gitlab, you get given a commit secret token that you can use to then write back to the repo that's been kind of built. So you can use this if you've got a multi-stage pipeline to say, right, I want my first action to be build this dependency and then commit it back into the repo for later stages. So we were trying to use those. We couldn't get anything because the code was running so quickly. The jobs were just dying, and then the tokens were expiring. They weren't any use anymore. But what we did find was AWS IAM keys that allowed us access to the Elastic Container Registry. So the way this pipeline worked was it was a bunch of Docker files. They get fed in, they get built, and then the built image gets loaded into ECR and then used later by their other clusters. What we couldn't work out was how workloads were getting put into the clusters themselves, because we couldn't see any like kubectl run or anything like that. Turns out they were using a pool-based CI solution called Argo CD, or CD, not CI, Argo CD. And what this does is basically spins up a new control loop inside the cluster and says, I want the latest version of this image to be running forever. And if you ever update an image in the registry, Argo goes, hey, I'm not running the latest version anymore. Let me just go off and retrieve that and come back. So in theory, that's more secure because it's much harder. You have to be in the cluster anyway to modify the CI/CD side of things. But at this point, we were able to modify something that was being pulled into the cluster. So we modified the image. Argo went, hey, wait a minute, that's not the latest version. I need the new one. And all we did in this case was just run a little hello world, we've got the flag sort of thing. But we could have quite easily been doing crypto mining, we could have been doing anything, just hoovering up customer information, whatever we wanted. So that was a nice route that didn't involve starting right at the start of the pipeline. We ended up using some web app attacks to get into the middle and then moving on from there. And the fourth one, this was fun because this was a brilliant engagement which involved a customer saying, you can't do that, that's impossible. Which is rarely the case, especially if a consultant's gone to the time of writing down with evidence, here's how I did this and here's how it definitely works and here's screenshots. So this customer was using Circle CI. Their developers were not allowed access to production environments. They could do whatever they wanted in dev, but only the main branch of their Git repos were ever moved to production. And there was an approval group. So anytime someone wanted to migrate from staging to prod, it had to go through approval, and it had to have two separate approvers. So we kind of thought, well, this isn't going to work because the chances of us being able to compromise a dev and two approvers is fairly minimal. That's not going to be easy. They used Circle CI, and we could read through. The Circle CI config file lives in the base of the repo that they were testing, that they were using these predefined standard templated tasks that their security team had written. Secrets were managed through Circle CI, so there weren't any secrets in the repo. There was just references to pull this secret from Circle CI. That's fine. And then, based on the Git branch that was being built, there was a variable code path. So, effectively, if you're doing dev things, you would load the image registry.customer.com/terraform, and you would use the environment variables dev AWS access key ID. I'm hoping some of you can see where this is going already. And then they ran Terraform apply, but that only happened when the branch was feature/dev star. So that's fine. The next bit of the Circle CI thing said, do prod things. If you want to do prod things, use prod AWS secret key and access key. And that's only when the branch is main. The theory being, there's no way for an average dev to get code into main without approval. So this is fine to do automatically. There's absolutely no problems here whatsoever. Apart from the fact that devs could change the pipeline config file on any branch. There was no like, oh, well, you can, the config file wasn't in a separate repo that they had no access to or anything. It wasn't protected. It wasn't under change control. It was possible for any dev to change this pipeline on any branch, and then Circle CI would pick up the task with the new config. All of the secrets are available to the pipeline because you never know when it's going to be needed. So we did the really, really, really clever thing of saying, I want to do hacky things. Why don't you just, on any branch, read me the production AWS keys, please? Obviously that worked. Why wouldn't it? The devs basically went, this isn't a thing, you can't do this, it's not possible. So I ran it in a test repo and gave them a link to effectively this page here, where I'd just grepped and said, grep out the last bits of the secret keys. And they went, oh, bother, because it turns out this wasn't just one team, this was their entire platform across all of their environments for every dev team. Turns out that they could all just dump the AWS keys. What makes this even better is because Terraform's automation-based and so on, their next argument was, well, we rotate the keys every hour because we don't need them to be long-lived because we're not using them all the time. Well, GitHub Actions has this, or Circle CI has this really nice thing where you can run jobs on a schedule. And they rotated the keys at 5 past the hour. So at 7 minutes past the hour, we wrote a job that just called out to a Slack webhook and sent us their new keys. Again, not very happy with us after that one. That was quite fun. Can probably kill that now, save some bandwidth. So yeah, basically there's a few different points we could get involved in this and start attacking a pipeline. Most of them tend to have started with we've got some form of access, either because the customer gave us it or we compromised someone. It's kind of difficult to stop a dev doing something when you're automating to this level. The solution for this customer, in this case, was actually to break out to a separate repo. So rather than saying, right, we're going to use branches as the trust boundary, they ended up writing some extra automation that said, right, when a trusted admin wants to do something, we'll explicitly clone the repo that only the devs have access to, that only works in dev, we'll clone that in, because I don't believe at the time Circle CI actually let you provide any other restrictions than this. It was literally the Circle CI config file had to be in the repo. Devs had to have access to it, so they had to provide separation some other way. So that was fun. This, I think I put in just in case my VPN fails. This is just to show roughly what the commands are going to look like when we are doing some attacky things. So let's see if I can actually demo these a bit more nicely. What I've got here, you'll notice I've got a stage called hacks in my pipeline. And if this works, I've written a few just very, very basic. This isn't doing anything fancy. Basically in this one, what I'm doing is just saying grep AWS from printenv. So if you get into a repo and it looks like there's some pipeline stuff happening, if you've got access to the logs, because some developers do, some RBAC configs don't let you have access, if you can view the job logs, then it's dead easy. Printenv is brilliant. Gitlab has this really handy thing where you can say this is a sensitive value, don't print it out, so it'll show up as like redacted in the logs. That's a regex at print time. So it turns out if you just pipe your command into base 64, it doesn't get redacted. So, obviously it doesn't match the regex for an AWS key anymore, so it's not an AWS key. So copy, paste, base 64, decode, job's a good one. If you don't have access to the logs directly, this is a little bit more awkward. Obviously, there's probably going to be something you can do. So we did a couple of jobs where we actually didn't know where the build environment was running. We couldn't see any logs. We just knew that the job was passing or failing. That's where things like webhooks come in handy, or DNS exfil. My favorite one is Slack or Discord or Teams, because the number of people who are using a GitOps-based approach these days, where if a build pipeline passes or fails, you get told in Slack, which means you need to have whitelisted slack.com in your firewalls. So I just make my own Slack workspace and then have a listener that says, hey, you've got this data. It's been retrieved. Good job. DNS also works, so subdomain lookups, if you've got a DNS server you control. Any of your traditional, I want to get data out past a firewall options are there. It might just take a while to work out which one works. And then I also have a demo quickly of so this, again, I apologize for showing you all a massive base 64 data. That is a Kubernetes service account token. So if you take that data and decode it, it's basically JWT. So the command around there was the cat var run secrets Kubernetes IO service account token. I have made this cluster admin on my environment. What I've run is kubectl auth can I at the end here, and just list everything I'm allowed to do. So I've got star.star. Obviously that's for demo purposes, but you would be amazed how often we see people who have provided things like the group system service accounts in Kubernetes, just cluster admin access. Or there's a couple of installers on GitHub for various data mining type things that just add in RBAC when you install them that says make the default service account have cluster admin, which is really stupid, and a lot of people don't notice that it's a thing. I've got a couple of outstanding GitHub issues that say this is bad, don't do this, and they've been ignored. Again, if you were speaking to me in the pub last night, you might know that I despise the Kubernetes RBAC model because there's no deny option. So if you've got the most fine-grained, well-defined RBAC in the world, and someone else creates something that says system authenticated has cluster admin, that's the rule that gets matched. There's no way of saying, no, I don't care what the allows say, this is a deny that just can't be done. So it's fairly easy to mess up. Again, I suspect this was set up for a customer who wanted to say, oh, it just works if we make it admin, so we'll just make it admin. At this point, if I grab that token, I can run commands on the cluster as cluster admin. I could be compromising production environments, build environments. I've got admin on your build environment. Good luck, have fun. So common themes in these attacks. This is where people get confused and forget about security principles, I think. A pipeline is remote code execution as a service. That's literally all it is. You feed in code, the code gets run. Any of the components should be treated the same as any other device on your network, and for some reason they aren't. So network segmentation, you've probably noticed a couple of times in this, that was a fairly big failing on the customer's parts. Why can your build pipeline talk out to the entire internet? The Firewalling is just the same. It's still servers running something. If you're in the cloud, access to cloud metadata is always a fun one to forget to block. So I've seen instances where people have an EC2 running that has ridiculously privileged IAM permissions. So you can just say, right, well, as part of my pipeline, I'm going to curl the 169.254.169.254 address, grab credentials, authenticate to AWS, ransack your environment. Cluster control planes. So you can block Kubernetes pods from being able to talk to the Kubernetes API server through network policy. No one ever does. It's a really good idea to do that. And just general firewalling, very first example where the build environment could reach out to the dev's laptop and retrieve things. It had no reason to do that because the theory was that you'd have everything uploaded to the customer's Artifactory or to the build pipeline itself. So firewalling, super important, really good idea. Don't forget about that. Component breakout is another one. I've not spoken about container breakouts because I kind of wanted to avoid scope creep. A lot of CI environments say if you want this to work nicely and you want to be able to run Docker stuff, just enable Docker in Docker. So Docker in Docker is really cool because it does exactly what it says on the tin. But unfortunately, it requires you to run a privileged container. If anyone was at Mary's talk earlier, you probably know privileged containers are not a great idea. If I've got a privileged container, breaking out is trivial, and I can just get roots on the host. So if you run Docker in Docker to spin up your containers and build new containers, then the chances are someone who gets into that container can break out, compromise the host. We see -- privileged used all the time. Again, not a brilliant idea. There are projects out there to fix this. So there's things like Canico for doing Docker building without requiring access to Docker directly. So there are options out there, but a lot of the times the happy path is just map this privilege in. It'll be fine. We'll have things running. And same VMs being used for multiple projects. If you've got anything sensitive, probably a good idea to put its own runners in. So if you've got these are my APIs I don't care about, but also this is the one that controls the master login for all my customer data, you should probably not be building them on the same environment just in case there is a breakout. But again, that becomes a cost decision. Is it cheaper to do it all in one environment? Yes. Is there an extra risk? Definitely yes. A lot of customers come down on the side of let's do what's cheaper. RBAC misconfigurations, I've spoken about these enough, I think. You're probably fed up. Kubernetes RBAC, Cloud IAM, probably important to keep them locked down. Again, the principle of least privilege still applies to everything. Just work out, does this build environment really need all of the permissions I'm giving it, or can I give it a subset? A good example of that one actually is Terraform. I've yet to find a good way of saying, I've got this Terraform code, I want to know what permissions my role that's going to run as actually needs. So my example there, all it needs access to is S3 and Lambda, an API gateway. It doesn't need access to everything. But when I was trying to build this, I'm very glad that I didn't accidentally create my secret keys because I just went, right, this is going to be AWS admin, because it works. If anyone knows of a tool that will say, here's some Terraform, I'll work out what deploy permissions you need, please let me know, because I'd really like to see one. And yeah, cloud, Kubernetes, the whole, whatever your relevant compute is, you're going to have some permissions somewhere. So in terms of defending pipelines, what can you do? Firewalling, you probably guessed I was going to say this. Definitely limit egress to only what's needed, especially with all of the supply chain issues that are going on at the moment. And I mean the security ones, not the I can't buy a car for 7 months ones. The chances are you probably don't need to be going and getting dependencies every time you build something. You should be mirroring them internally. So have an Artifactory, have an SFTP server, have whatever you want. Make sure your dependencies are somewhere local. Again, this has the double benefit of, if they're local, the chance of them being modified by someone else are lower. So the odds are you've probably got better control over your dependencies and you've not got things like, was it the pad left thing in Node where some developer got really angry and broke something that was used by about 18 million Node libraries and they all just stopped working. There was one recently in AWS as well, I think. So the AWS CDK stopped working because it was node-based and someone changed the dependency upstream and just no one could build AWS stuff anymore. So yeah, firewalls, restrict access between your build environments, restrict access to the internet. Don't let your build environment talk around to your Active Directory or places like that. Limited permissions, work out what permissions does each component really need. If you need to deploy an image into a container registry, can you do RBAC on a per image basis? So instead of saying, oh, I can write any image I want to anywhere in this registry, only allow the build component for your phone number API to deploy the phone number image rather than saying everything. Sit down and work out what the blast radius of something being compromised would actually be. What permissions would an attacker get if they compromised something? And please, 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 please don't use privileged containers, because we see this all the time. And I know it makes things work, but also it's just a really bad idea. Like, don't give all your devs root on every single server you run. That's just not great. And threat modeling. Threat modeling is something that I think is super important when you're building out pipelines and really overlooked, because people want to move faster. They want to be able to deploy code faster. They don't want to sit down and work out how this could go wrong. They just want code. So work out where an attacker can come from. Are you talking about external dependencies, internal code? Are you worried about a malicious insider? What's your approvals process like to get code into the pipeline? What components can they talk to? If you're using EC2s, can they talk to the wider cloud platform? Can they scan around your environment? Can they talk to Active Directory? Again, we sometimes see Active Directory credentials being used to retrieve things from file shares, but those creds are excessively privileged. And what further access would an attacker gain by being in the pipeline somewhere? Chances are, as a minimum, if an attacker is in a pipeline that's building something, they're going to be able to modify the thing that's coming out the other end. At the very least, make sure that that's the most they can do. Try and make sure they've not got your entire environment compromised. And this is a quick one. This isn't really for defending your pipelines. Image signing is something that's getting spoken about an awful lot. Cosign seems to be being used everywhere. I love the idea of being able to sign all of your dependencies. But if I've compromised your pipeline that automatically signs things, you've just signed my malware for me. So image signing is great for saying the thing that came out of the pipeline versus the thing that's being deployed are the same. But what it doesn't do is confirm that the thing that came out of the pipeline is doing what you think it's doing. So again, testing, auditing, access controls, making sure that you know what your pipelines are doing and jobs are logged is super important. I think I don't have a slide on logging. So basically log stuff as well. Log as much as you can without making it excessive and just generating a million alerts for your per SOC. So, quick conclusion. Pipelines are privileged. They have to be. Pipelines can deploy stuff for you, and you want that to happen. You need to lock them down as much as you can to make sure the things being deployed are only what you want and not entire estate compromise. Audit your pipelines. If you've got a dev who likes just pushing the limits, get them to sit down and just work out what they can actually do. Let's face it, that's how a lot of pen testers started, because some people have that itch that goes, what does this button do? I'd better not press it. But some people go, what does this do? I'm going to press it until something catches fire. Find the button pressers and get them to try and break out the pipelines, and then make sure you actually fix what they do. Yeah, isolation, lock stuff down, the usual. It's the same as running any other system. Make sure that your permissions that you're giving to something are only what it needs. So that was that. That's been 50 minutes, which isn't bad. Any questions? If you don't want to shout them out now, I'm on Twitter, I'm on email, I'll be in the pub later. Any questions? Yes?
Thank you for the presentation. I have just a few questions. And others around when you mentioned limiting access to Active Directory.
Yep.
For organizations where you manage everybody's sign-on as single sign-on, and then both dev and everybody who have access to application and services have to authenticate against it. How do you manage this element? Then secondly, I don't know for how many who use AWS here. One of the struggles I am facing is change management. Being able to ensure that dev people are compliant with change management process, since they have access to the CIC. So what is the best approach? Then finally, is there a better way for the security team to be able to know exactly when there is an inconsistency in the pipeline? more or less like timely information as to going to know that there is already an issue.
So first question was limiting permissions through Active Directory single sign-on. So that one I would say, at the very least, make sure you understand when you give a user or a group access to a pipeline, you know what that pipeline can do. And again, this comes back to auditing the pipelines themselves. The point I was making about limiting access to things like Active Directory originally was if you're giving secrets to your pipeline to run, make sure you understand what those secrets can access. So if a developer can access a pipeline that is itself domain admin, that's an escalation of privilege for the developer. From a single sign-on point of view, it kind of doesn't matter if you're using GitLab's built-in authentication or if you're using SSO. It's a case of these devs can make this component do a thing and understand what that component's able to get access to. Generally, you should be using something like only devs who are actively working on a project can make commits to that project repo rather than the entire organization can. I think that's the best you can do other than using commit logs to make sure you know who's making a job run. Which again, if your SSO should feed back to say, oh, it was Dave that started off and did this commit. What was your second question? Sorry. AWS change management. Git commit logs. Make sure that if you're going as far as you want to have commits be signed by a developer with a PGP key, make sure that all of your commits are from a trusted source. That will not help you if an attacker compromises a laptop. Obviously, you can do things like YubiKeys or some other form of authentication to make it harder for an attacker to be able to make the commits. One of the good things about CI pipelines is they generally run off a Git environment anyway. So your change control is kind of built in terms of they need to make a commit and change a config file.
And the AWS change manager in any way now?
I don't know. I haven't looked into it. I will add that to the research list. And your third question?
Security monitoring.
Yes. Code review can help. Obviously, you might end up with a somewhat meta stage of, do you want to add something into your CI pipeline that actually does checks for anything malicious itself? So you could do things like grep for the metadata URI and say, in the first stage of a build, you could say, if this code is going to try and talk to metadata, and I don't think it should, you can do an alert. If you've got a Kubernetes environment that when you run a deploy, it's going to create a dangerous role binding, you could use a tool like kubesec to detect that in the pipeline. That's enough to stop someone who doesn't understand exactly what the pipeline's doing. But ultimately, if the developers have the ability to control the pipeline, they can circumvent those checks themselves. So at that point, you really need to start looking at forgetting about the CI side of things and just doing any form of malicious detection however you normally would in your environment. So if you've got some kind of endpoint detection, run that on the servers as well. Network monitoring, firewalling, any form of audit logs you can ingest. Obviously, if you log everything, that gets prohibitively expensive. But logging on, I guess, certain commands being run, remembering even if you're running something in a container, or I guess it's maybe slightly different if you're using managed containers, but on-prem definitely, the containers are still just processes. So you can run your malicious process detection in the exact same way in Kubernetes versus a dev SSHing to a box. I think that would be a hard problem to solve categorically inside the pipeline itself, though, and would fall back to traditional defense and kind of blue team activities. Did that kind of answer your question? Yeah. Kind of. Any other questions? Brilliant. Thanks very much. If you've got anything, I'll be in the pub.